So how we can do it in the Jupyter Notebook? Basically, what I do usually when I want to run my codes in Jupyter Notebook, and it works in my computer. I don't know about your computers and how you installed Jupyter Notebook. If you have installed using Anaconda, maybe this procedure doesn't work for you. Um, so what I do, I usually go to the uh, folder that I have got my, for example, data, and I want my Jupyter Notebook and data frames be saved there. So basically, this is my task folder. And here in the address bar, I type CMD, enter. So when you do so, your terminal would be open, and here I would type Jupyter Notebook, enter. So as you see, my Jupyter Notebook environment or folder will be open on my browser. And here I can, for example, select new notebook or open existing notebooks. All right. All right, now I have got a new notebook. I can start importing my libraries. So import NumPy as NP, import pandas as PD, and run them. Then I need to enter my data file. df is equal to, so I'm using PD, read underline Excel. This is the function to read the data file. And the name of this data file is AFE7518. So I have got this name. Yeah. So I just want to copy this name and put it here. And it's in the sheet name. Also, if you have got different sheet names, you need to enter the sheet name. The name here is raw underline data. Hopefully it's going to work. So I have got df. Let's check. Yes, so I have got my data imported to the environment. And then we can go for example, another library, as I said, matplotlib dot pyplot as plt. And as I said, we enter percentage matplots, matplot library inline. So what this code does, actually any graph would be shown as output here in our current working notebook. And then I'm going to plot, for example, so say df dot plot scatter, yeah, df plot scatter, either using this plt or, okay, let me run this code first. So now you can use basically this library as we showed before. You can use this library, or you can actually use the pre-default library in the Python, which is plot scatter age versus salary. And let's run it. So we have got age versus salary, or same as what we have done before. What you can do is to use PLT library in order to basically uh, um, draw this graph that I'm going to sh show you how do so. So what we do is to defining, for example, x is, or simply say age, if you want to have the same names, age is equal to dfh, and y is our salary as variable, is df salary, and we now we are going to use the library plt, right? Plt dot scatter, and we can put uh, age and salary. And hopefully, okay, so sorry, salary hopefully works like this. Yep. So both of them are the same using either plot function, which is a default function in the Python, or using PLT. I should end up with the same results. Of course, the PLT has got more options and it's very advanced package for developing further graphs and etc. Later, I want to do stats model. So I wanted to do my regression. The package is stat models API as SM, stats models API as SM, and X would be SM dot add underline constant X. And we can run regression now. So our regression would be equal to SM dot OLS, Y, and X as cap. And finally, we can say, okay, reg.summary or print reg.summary. Both of them should end up with the same result. Let's see if it works or not. I'm waiting for the results. So it says that X is not defined, and it's correct because we didn't define X. We put age here. So one thing you can do is to define X here again. X is equal to basically df age, and Y is equal to df salary. So the column age in the data file df is our X variable, and the column salary in the data file df is our Y variable. And we can run this one again. Okay, object has no attribute summary, and I just want the here. So let's yeah, so reg doesn't have SMS OLS X1, sorry, dot fit. I forgot that one. And let's run this one. As I said, if you put like, for example, print, usually we have got nicer presentation of the final. All right, so dependent variable salary, and our independent variable is age. Coefficients are the same as what we did in collab, and is significant, and R square is 54%. This is how we can run regression in Jupyter Notebook, which is same as the collab.